Hello, everyone. It's really my pleasure to talk about women and STEM, or science, technology, engineering, and math. There are so many accomplished women in STEM in Canada. This image shared by the Canadian government just last year on their social media just shows a few. And I want to point out some of the impressive things that these women have achieved. They've researched everything from antibiotic-resistant bacteria to healthcare access in Indigenous communities, to greenhouse gas emission in farming. They've discovered radon, they've named stars, they've designed planes. I want to highlight one woman in particular that's made a big impact on me, and that is Roberta Bondar. Roberta earned a PhD in neurobiology and then became a medical doctor and specialized in neurology. She was then recruited to a space program and became an astronaut, and did some pretty exciting experiments aboard the Discovery Space Shuttle in 1992. Dr. Bondar was Canada's first neurologist in space and Canada's first woman astronaut in space. When Canadian Geographic interviewed Dr. Bondar in 2016, they asked about the biggest challenge she's faced in her career. She didn't mention the complexities of the nervous system or the constraints of space. She mentioned that the biggest challenge she faced was not receiving the same opportunities or given the same dignity as men. Women have made huge gains in the workforce in recent years, in the last century, but some challenges still remain. And it's those challenges that I'll talk a bit about today. So I'll talk about the challenges that women in the workforce still face, but I'll focus on STEM workforces, STEM workplaces in particular. The first challenge is one you've probably heard about, and that is less pay. Men make more money than women. Perhaps you knew about this, but did you know that this wage gap, has been widening and worsening in recent years? Let's look at some data from Statistics Canada. We can see that the average wage of men minus the average wage of women per hour, averaged out for all occupations, has been getting worse in the last 4 years. And you can see in science in particular, we see that same trend. So last year, working men earned more than $5 extra per hour than working women in science. There are 3 careers where women earn more money. Maybe you can think of them: therapy, nursing, and allied health. So you can see some of the increased earnings there for women. So they range to less than $2 or less than $1 per hour. Men earn more in all other occupations: in business, in management, in agriculture, law, education, protection services, sport, art, music, manufacturing. I could go on. In Canada, for every $1 that men earn, women earn 87 cents. The second challenge that I want to highlight is less credit. The Association for Women in Science out of the US found that 68% of white women and 73% of women of color have had their ideas or accomplishments credited to someone else. Women have been pioneers in many disciplines, but in situations where they may not have funds to publish their research in really big journals, or if they do, but then that research goes unnoticed, then they can get scooped by someone else, who then gets credit for popularizing their perspective. It's data like these that has led to initiatives like #CiteBlackWomen, because it's these excellent scholars that are most likely to have their ideas stolen. Here is one interesting example of less credit in my field of cancer biology. When you check out the list of Nobel laureates supported by the American Cancer Society on their website, you see 53 amazing researchers, 52 men and 1 woman. I want to point out a particular entry on this list: Dr. Jack Szostak. He won the Nobel Prize in 2009 because he, quote, helped discover how chromosomes are protected by telomeres and the enzyme telomerase, end quote. You may ask yourself, who did he help? Elizabeth Blackburn. She actually discovered telomeres, and then she reached out to Jack, and together they figured out how telomeres work in cells. Elizabeth Blackburn and Carol Greider then worked together to discover the enzyme telomerase. So you may ask yourself, why aren't Elizabeth Blackburn and Carol Greider on this list? Did they never receive funding from the American Cancer Society? If so, why? That's a problem. Or perhaps they did and they were just simply forgotten. Of course, that's a big problem too. Studies have shown that women are credited less in science than men. And let's look at some of the interesting results from the Nature article I cite here, published 2 years ago. The researchers did a lot of work. They looked at finance and human resource data to figure out who was paid to work in science and who was on what team. And then they looked to see what those teams produced, their publications, their patents, things like that. So this graph shows along the x-axis women's potential share of authorships. So the more women working in a particular field, the higher the number you would see on that x-axis. Let's look in my field of biology. You can see here that on the x-axis, women's share of potential authorships is close to 0.5. So there's close to 50% of women working in that particular field. But when you look at the y-axis to see their share of actual authorships, you see it's below 0.35 or below 35%. Ideally, we'd see this bubble and all the others for all the different fields nicely along that dashed line, the work they do directly corresponding to authorship and credit. But that's not what we see. Every single one falls below. No matter what the researchers controlled for, say time on the particular research team or time spent in the lab or seniority, this trend persisted. When the researchers controlled for a particular job title and say compared men lab assistant to women lab assistant, they still found that men had a 10% higher chance of being named as an author on their team compared to the women on that same team. And I knew that things like this happened, but when it happened to me a couple years ago, it really hurt. And you see it up close firsthand. Women can do the same job as men, but get less pay, less credit, and they also get less citations. Even when women do get credited with authorship, their work is more likely to not be recognized and to not be cited. There have been several rigorous studies done in recent years that have looked at citations of scientific papers. These papers usually have several authors. There's a first author who likely wrote the paper and did a lot of the work. And then there's a last author who likely supported, funded, supervised the work. And there's usually several authors, a dozen, several hundred in between. So the order of authors has meaning, particularly that first and last position. So keep that in mind as we look at some of the results from this particular paper published in Nature Neuroscience a couple years ago. They found that neuroscience papers published in the top 5 journals in that field, those that had a man first and man last author, as you can see by the first bar on the graph, MM, were more likely to be cited, were cited more often than you would expect, just based on random statistics. And then you can see in all the other bars that if there was a woman first author or a women last author or both, WW, in the last bar, you can see that papers with these authors were cited less than expected. So a man could write one article and a woman could write another. They could both be published in the same journal at the same time on similar topics, and the man would statistically receive more citations than the woman. And citations matter. In science, there's such a thing called the H-index, which takes into consideration not only the number of papers one publishes, but also the number of times those papers are cited. So the more papers, the more citations, the higher the index, and scientists will often use this metric to help achieve promotion. Speaking of promotion, women are less likely to receive promotional opportunities or promotions, period. And one of the reasons behind this is unequal expectations in the workplace. 4 female professors wrote a book about their research on the topic, their book titled The No Club. They document that women are disproportionately asked and expected to take on extra tasks that often go unrewarded in the workplace. Tasks like making coffee, planning an office get-together, taking minutes in a meeting, peer reviewing grants or papers, helping a colleague, cleaning up a mess, organizing a conference, and more. On average, women spend 200 more hours each year than men on non-promotable work. This is the equivalent of a month of dead-end work each year. This leaves women overcommitted to this work that is unrewarded and not promotable. In addition to these unequal expectations, there's also unequal evaluations. Many studies have found worrisome gendered language, discrimination, doubt raisers in reference letters, performance reviews, and teaching evaluations. And as a teaching-focused professor myself, I'm particularly intrigued by the data on teaching evaluations, so I'll show you some of that here today. Researcher Ben Smith compiled feedback from the website ratemyprof.com and found that across disciplines, students use the term brilliant much more often to refer to their male educators, see the blue dots, compared to their female educators, see the orange dots. And if you're wondering if this is just a case for the term brilliant, no, if you use any synonym intelligent, smart, the results, the pattern are the exact same. In contrast, students use the term bossy much more frequently when referring to a female educator compared to a male educator. You can see that areas of my expertise, like health science and biology, don't look great here. But you see that even outside of the sciences, pretty much in every academic discipline, we see these worrisome trends. An article in the New York Times had the perfect title to describe these data. Is the professor bossy or brilliant? Much depends on gender, and I would add bias. Therefore, not surprisingly, women tend to struggle and feel like imposters in disciplines that value brilliance. This is number 6 on my list, imposter syndrome. The self-doubt where people feel like they're not good enough, not smart enough, that they don't belong, that they're a fraud, that they're an imposter. The news article I show here mentions a research study that found that as the perception of brilliance increased and got quite high in fields like philosophy and physics, so too did the imposter feelings. Imposter feelings aren't unique to women. Of course, anyone can feel this way. But these negative feelings did increase more for women in this study. The second last challenge that I want to highlight today is a little bit more heavy and more serious, and that is the topic of harassment. Harassment can happen to anyone in a workplace. Scientific workplaces are no exception. Sexual harassment is one type of harassment, and that can include sexist jokes, repeatedly asking someone for a date or for sexual favors, or inappropriate sexual comments about someone's body or attire. McKinsey and Company found that 37% of women that they surveyed earlier this year reported sexual harassment in their workplaces, in their career. And this was a slight increase from the same study that they did a few years prior in 2018. So these numbers are obviously problematic. What's even more problematic is that harassment seems to be particularly common in the sciences that involve fieldwork, such as anthropology, ecology, geology. Clancy and colleagues found that 71% of women and 41% of men experienced harassment in the field. A number you don't see here is that 17% of women said this happened regularly. You see other disturbing numbers here. 6% of men and 26% of women reported assault in the field while they were working. That's 1 in 4 women. The last challenge I want to highlight is really a culmination of all of these. When you put all of these together, you get burnout. People who are constantly stressed and overworked end up feeling exhausted. Researchers Robin Ely, a professor of business administration, and Irene Pavidic, a distinguished professor of sociology, regularly explore challenges in the workplace in their research, and they found that the real culprit was a general culture of overwork that hurt everyone and locked gender equality in place. Not surprisingly, when you think and reflect about all these challenges, we find that a lot of women leave. We see this at the undergraduate level. Here we see some data about women departing STEM undergraduate degrees compared to men, so there is some difference there. We see a similar trend once they graduate from their undergraduate degree, and if they make it through graduate school and get into the workforce, we see many departures there for women as well. One of the reasons that women report they depart is due to the lack of promotional opportunities. Here we see some data about individuals in various levels of leadership in the workforce. This is data from life sciences, so again, my area of biology. And here you see a lot more men in senior leadership positions. Women get tired of waiting for the promotional opportunities that will never come, so they leave. The departure is particularly high for women in the workforce who are mothers. This isn't unique to the field of science. We do see this in many disciplines, but this particular study found that more than 40% of new mothers with a stable, full-time job in science either moved to part-time work, moved to a different career, or left the workforce entirely. And you can see the effect here is much greater for mothers than what we see for fathers. So how can we improve? What do we do with all of this? Well, I have some thoughts based on my experiences and based on everything we've talked about here today. I think first and foremost, we have to work really hard to hire and also retain a variety of people, diverse people. We know that when we put people who think differently and who have lived different lives and have different experience, when we put them together and when they work together in groups to solve challenges in the workplace, they will inevitably make those workplaces better. We also must acknowledge and close the wage gap and work towards really equitable promotion policies, or perhaps a diverse team makes promotional decisions and promotional offers. We must cite diverse sources. Why would we limit our scholarship to the scholars we already know about, the scholars we can easily access, or the scholars that are most popular in our fields? From the majority of fields, those are men. We must mentor women well and ensure that they're not shouldering the majority of volunteer opportunities in their workplaces, and that they say no a little bit more often. And then lastly, if you see something, if you see discrimination, harassment, you have to say something, because that's how we break the cycle and that's how we make workplaces better. As I wrap up, I want to share the wise words of Marci Ien, Canada's Minister for Women and Gender Equality and Youth. Earlier this year at the United Nations Commission on the Status of Women, Minister Ien said, "Our position, Canada's position, is that gender equality is non-negotiable. It is a fundamental human right, and it must be protected." I'll conclude with the same photo with which I began, my Lego set of a woman in a science lab. And I think she kind of looks like me. We've come a long way. Women can wear pants, women can earn degrees, women can get a job in science, women can even be a leader in science. You can buy a science Barbie, you can buy a woman science Lego set like I have. But there is still so much progress left to be made, right? We can make improvements to wage, equal credit, due citation, less harassment, burnout, and more. Let us not tire of doing this good justice-seeking work. Thank you.